I'm gonna go fast because I don't want that video to be too long. It's just graphing. So we're graphing quadratic equations. They want you guys to know what's the axis of symmetry. They want you guys to know what's the vertex. They want you guys to find the y values and to graph them. Label this and label this, and you're done. So quadratic functions. So remember, this is a general term, not the general how they look in general. This one right here. So he has an ax2 squared plus bx plus z, where a, b, and c are numbers, and a cannot be 0 because then it would stop being a quadratic function. Okay, so they're going to give you the parent function, which is this one, and then they're going to give you another function, and then you're going to compare these two. This is, you've seen this in Algebra 1, in Algebra 2. I'm sure you've seen it at least 2 times before this class. So for this first example, I'm going to show you, so these values, because somebody asked me on the other class, where am I getting these numbers from, the x's? So again, those of you here now, please listen to me. This, you choose them, you make them up. You make these x's. So the book just gave me these values, but they just happened to pick those values. Like they could have picked, I don't know, they could have said here 5. It doesn't matter. You could have picked your own values. I would say always pick negatives and positives, and I would say make sure the negatives are the same as the positives or the opposite. So -2, 2, -1, 1. That's what I mean. Try to include 0 there all the time. So this is, we choose these x's, and then we're going to substitute here. I'm only going to do it once for this example. So -2 square, because this one has a square, that's the x. We put x, the -2 here for the x, and then you evaluate this gives me 4. And then -1 square, this gives me 1. And then 0 square gives me 0. 1 square gives me 1 again, and 2 square gives me 4. These answers are the y values when you substitute the x into that function. Now let's find these ones. So this is -2 squared plus 6 gives me 4 plus 6 gives me 10. So 10. And then -1 squared plus 6. So 1 plus 6 gives me 7. And then this one gives me 0 squared plus 6. And I should have made one of you. Let me see. Nobody's trying to get in. No. So this just give me 0 plus 6 gives me 6. So these are the values that I got. And 1 squared plus 6 again would be 7. And 2 squared plus 6 again would give me 10. So we substituted these x's, and these are the y's that we got. Now let's graph it, and then we're gonna find these ones. So I'm gonna graph this. This is what the book wants you guys to do. So I'm gonna label the x and the y axis. This is the x, and that's the y. And then I'm gonna plot these points for this function first. This is the parent function. So -2, +4, -1, 2, 1, 2, 3, 4. That would be the first point. -2, +4. So this is -2, +4. Then -1, +1 right here. So -1, +1. And then 0, 0. So this is 0, 0. And then 1, 1. 1, 1, and 2, 4. This is 2, 4. So that's that. So now that's a parent function. So now let's graph the second function, the one that has a plus 6. So negative 210. So let me use a different color for that one. So negative 210 would be negative 210 right here. And then negative 1, 7. 7 here. And then 0, 0 again. So right there. No, not 0. 0, 6. Sorry, guys. 5, 6. Right there. 0, 6. Because we're doing this one. So I got confused with that. And then 1, 7 again. So 1, 7 here. And 2, 10. Right there. So that's the other graph. And this is where now you should understand that the 6, this 6 here means that you move the graph 6 units up. So whenever you see a constant number, so this is a constant, it has no letters, it's not attached to anything. This is a constant. Whenever you see that, that would become the vertical shift, where you move every dot, you move it 6 units up. If you guys notice, this dot move 1, 2, 3, 4, 5, 6 units up. Any dot to its corresponding one would be 6 units up. 1, 2, 3, 4, 5, 6. This one, 1, 2, 3, 4, 5, 6. So everything moved up 6 units. So again, you're gonna have to remember that when you see a number, a constant like that, that means it's gonna move the graph up and down. And you can move it down here. It could also move it down. You can move it up. Okay. The vertex. So remember, this is not in vertex form. It kind of is. This one. So this is the function that looks like this: x squared plus 6. And this is just the parent function, the x squared. So the x squared plus 6 and the x squared. So it asks you for the vertex of this purple one. It would be this dot where it turns. So it would be what? 0 and 6. That's the vertex of this graph, which is this dot here. 0, 6, this is a vertex. For this one, it's obvious it's this one. This is a vertex for this one. The 0, 0. The axis of symmetry, it's the line, the imaginary line that cuts the graph in half. So it would be for both, it would be the same. It's a line that cuts the graph in half. This one, and it's this one. If you guys notice, this line cuts the graph in 2 parts and they're equal to each other. This side is equal to this side. And that imaginary line is cutting it in half. Mathematically, this is how you denote it. X equals to h. The h, so remember the vertex is the hk. So the h is just the x value of the vertex. So for this purple one, what's the h value? 0. So the axis of symmetry for this graph would be x equals 0. For this graph, and for that one it would be the same, the axis of symmetry. So let me put it in red for that one. So for this one, let me put it here, axis of symmetry would be x equals 0, and the vertex would be the 0, 0. For this one, the axis of symmetry, it's the same, and the vertex would be 0, 6 because we went up. So 0, 6. Okay. So that's that for that example. Now let me move on to this ones. So again, I'm gonna have to graph for this one, because if not, I'm gonna run out of space here. So for A and B, I'm gonna graph the parent function, the one that I had before. So I'm gonna graph the parent function. It starts at 0, and then 1, 1, and then 2, 4. This is a parent function. This is the x squared function. Okay, and then I'm gonna graph these two, and we're gonna compare how they look. This is example 2. Okay, so I'm not gonna do the table for this one, so I'm gonna just copy them over here. F of x. So I'm gonna graph that, and also I'm gonna graph this one, the B part. Okay, so this one, if you were listening to me, the only difference between this and the parent function, this is that we're gonna move every dot 2 units up, and for this one, we're gonna move down 3 units every dot. So this one is gonna move for this one 2 units up. 1, 2, 1, 2, 1, 2, 1, 2 units, and 1, 2 units. So the blue one would be this one, x squared plus 2. And then this graph, we're moving it 3 units down. That's what the 3 means. Every dot. 1, 2, 3. 1, 2, 3. 1, 2, 3. 2, 3. And 1, 2, 3. Right there. Okay. This would be the x squared minus 3 function. That's how they look different. So that one moved up 2 units. This one moved down to 3 units. Now, what's the axis of symmetry for this one? And what the vertex? Because they're going to ask you for these two things for every question. So the axis of symmetry, like we said, it was the line, the imaginary line that cuts this graph in half, and they all have the same axis of symmetry. How do you denote that? By doing x equals, so x, both of them equals the h, or the x value of the vertex. So this is the vertex here. The vertex would be 0, 0, 2. That's the vertex. This would be 0, negative 3. This is the vertex. This is also the vertex. This one, 0, 2, and 0, 3. So for this one, it would be this blue one. It's 0, 2 for the vertex. For this one down here, it's this one where you move 3 units down. The vertex is 0, negative 3. The axis of symmetry is just the x value of the vertex. So this is x equals 0, and the same with this one. And just as that's the difference. Hopefully it makes sense when you see a number that it moves the graph up and down. That's all you need to know for those. Now let's move on to example 3. So example 3, there's a difference. Now we're dealing with parentheses. So now this number is not by itself over here. So here for this function, we would have a 0 because we don't have it. This is the one that moves the graph vertically. the vertically, right? Or vertical shift. But we don't have it. We just have this part. This number here, it's the value that moves it horizontally. Horizontal shift. So now instead of moving up and down, now this example is going to show you how it moves sideways. So we know the parent function. Let me graph again. The parent function would be 0, 0, 1, 1, 1, 1, and 2, 4. So this is the parent function again. This is the x squared function, which is this one. So this gives you 4, 1, 0, 1, and 4, which is this one. Okay, now they give you different values. If you guys notice these x's, for this function, they're giving you different x's. They start from 0. They're not starting from 2 anymore. You gotta be careful. They're changing what x's they want you guys to input here. So this is example 3. I'm not gonna go over how, maybe the first one. So how do you solve this one? So you would substitute the 0 for the x, like that. So 0 minus 2 squared, that would give you negative 2 squared, which gives you 4. So you know this value would be 4. And you would do the same for each substitute for the x. I'm just going to write the answers. This will give you 1 if you do that, 0, 1, and 4. So we already graphed this one. Is this one? Now let's graph this one. So 0, 4. 1, 2, 3, 4. And then 1, 1. Positive 1. Let me see if I got the right answer for that. 4, 0, 4, 1, 1. Yes. So 1, 1 would be here with this point here. And then 2, 0 right there. And then 3, 1. So 1, 2, 3, 1. So remember, this is the x-axis. This is the y-axis. Okay, and then 1, 2, 3, 4, 4. 1, 2, 3, 4, right there. So this is the other graph. This is the x minus 2 squared. This one, the red one. So all they want you guys to know is that when you have the number inside the parentheses, the graph is going to move along the x-axis. So in this particular case, it moved 2 units to the right. Now this is something that you guys should know or remember. Now try to remember the horizontal shift, the movement along the x-axis is always the opposite of that sign. So if you guys notice, this has a negative sign, but we're moving to the positive side of the coordinate, to the right side. If this was a positive, then you will move to the left side, the negative side. So it's always opposite of that sign. That's where you move it. So do not move 2 units to the left. It's always the opposite. If it's negative, you move to the right, positive. So that's what it tells you. Now, the axis of symmetry of this one would be this dot, the vertex, I mean. So the vertex, so let me write it down, the vertex of this graph and the axis of symmetry. The vertex would just be that dot, which is 0, no, I mean 2, 0. So positive 2 for the x value and 0 for the y. That's the vertex. The axis of symmetry, again, it's just like the other one, is a line that cuts the graph in half. and it's denoted by x equals, and it's always the x value of the vertex. So what line cuts did it have? X equals 2. That's the axis of symmetry, the line that cuts the graph in half. So these are the things that you guys need to remember how to do. So this is just more of the same. So let me just do this one. I'm not going to do that one because that one would be just like the red one. So I'm going to do A, different pen, do black. So now in this case, this one was a positive. You guys remember X, no negative. So actually, I'm not doing this. I don't want that. I want the positive one. That's what I meant. So this one, like the one before, it was X minus 2. The red one, and we move to the right. I just want to show you when it's positive, we're going to move to the left. So let's do a table for this one. I'll try -2 to see if that works. So I'm picking these numbers myself. They're not giving it to me. I'm just choosing those numbers. Like I said, pick negatives and positives. And then I'm gonna substitute them in here. So -2 plus 1 square gives me -1 square, which equals to 1. This one is -1 plus 1 would equal 0 squared, which gives me 0. This is just 0 plus 1 gives me 1 squared, which gives me 1. And then this one is 1 plus 1, which is 2 squared, gives me 4. And this is 2 plus 1, which gives me 3 squared, which is 9. So I'm not going to use that one, I think. So let's plot these points. So -2, 1. That one goes here. -1, 0 right there. 0, 1. 0. What's 0, 1? So -1, 0. Okay, so -2, 1, -1, 0. 0, 1. So I did something wrong. So that would be -2. Hold on, guys. So this is -2, give me -1. -1 squared is 1. And then this would just be 0. And then this would give me 0, 1. 0, positive 1. One doesn't look right. And then 1, 4. Oh yeah, I get it. So 1, 4, and then 2, 9. So this one, since it moved, it kind of confused me, but I got it now. So I should have picked a -3. So if I put -3 here, like before the 2, it would have given me plus 1, I mean -2 squared, which is 4. So -3 would have given me positive 4, which is this one. And this is how they connect the graphs. So compared to the parent function, which is the purple, so this is the x plus 1 square. It moved, the plus 1 moved the graph, you guys notice, to the left. And I did it by plotting the points, and it still moved it to the left. So that's why I'm telling you, when you see this sign, do the opposite. So if it's positive, move it to the negative side, the left. or just the left. Doesn't have to be negative, but it's going to move towards the negative side. So this is this one. That's how it moves. Now for this one, the axis of symmetry, because it's going to ask you, and the vertex. So the axis of symmetry again is a line that cuts the graph in half. And the vertex is this point right here, which is -1, 0. So the vertex would be -1, 0, and the axis of symmetry is always the x value, which is -1. And that's for this graph, which is right here. So that's the vertex. Okay, so I show you that now. I'm going to connect everything together. Well, I still need to do this one. Now. So I don't know who's paying attention, but I'm going to do this one. So this one's, they're talking about the a value. So right next to the x, there's a number. In this case, it's a 3, and in this case, it's a 1/2. On the notes, I think I posted these notes. I think they're on this side. On the notes, I wrote what everything means for the a. So the a is the leading coefficient of the, it's even here. It's a leading coefficient for any quadratic equation or function. And if the a is positive, you guys, the parabola will open upward. If the a is negative, the parabola opens downward. Those two things. Positive, it's going to open up like that. If the a, this a is negative, it's going to open down like that. Now, if the a, this same a, is bigger than 1, the graph becomes like thinner, narrower. So, like really thin like that. If the a is less than 1, the graph would become wider. Narrower and wider, so it's going to be fat. Fatter, wider, I don't know how to say that. There's more technical words, but I'm not gonna, about like the vertical stretch and those things, but I'm not gonna go over that. Just remember narrower and wider. If the a is less than 1, it's narrower. So wider, I mean. So looking at these examples, these are the a's. The 3 and the 1/2. You guys paying attention, Michael? O ya me dejaste hablando solo?
I'm listening.
So, hopefully, not, but yeah. Ni modo. So, this graph should be based on the rules, this graph, because 3 is bigger than 1. This graph should be narrower. Narrower. And this graph, 1/2 is less than 1, so this graph should be wider. If you guys notice, this is just the parent function. So I'm going to graph the parent function first. So the parent function just starts from here, and then 1, 1, and then 1, 2, 3, 4, 4, like that. This is just a parent function. And we're going to compare what the a does to the graph. So this one, it gave you, I already had the numbers here because I don't want to do it. So this one, if you substitute that -2 into that x, it gave me 12. So -2 gives me 12, which is all the way here. -1 gave me 3, 1, 2, 3. And then 0, 0, and then 1, 3, and then 2, 12. So if you graph it, the graph becomes, like I said, narrower, like thinner. So this is this graph, 3x squared. It becomes narrower. When the a is less than 1, it becomes wider. Let me see. So negative 2, negative 2, 2, so negative 2, 2 about here. Negative 1, 1 half. So right there, 0, 0 again, and then 1, 1 half, and then 2, 2. So this graph looks like this. So this is the 1 half x squared. So when the a is less than 1, it becomes wider, the graph. So the red one is the original of any quadratic equation. That's the parent function. And this is what happens when you change that a. So this becomes wider, black one, and the blue one becomes narrower. Okay, the axis of symmetry for these three would just be 0, 0. I mean, the vertex would be 0, 0 for all of them. And the axis of symmetry would just be x equals to 0 again. So for all these three, the vertex would just be 0, 0 for all three. And the axis of symmetry, it would be x equals to 0 again. And that's it. Now for the last thing that I'm going to do today, and then I'll make you guys do everything. You might get one. I'm not going to do it. You might get one that has everything. Like that. So this one has everything. And I'll show you how to find the vertex with this. This is actually easier to find the vertex. I'll show you right now. I just wanted to show you what happens when you have a negative in front of the A. So example 7, let me write the answers to this thing. If you substitute this into that x, that gives me negative 8, negative 2, 0, negative 2, and negative 8. So let's graph this. So negative 2, negative 8, 6, 7, 8, negative 1, 2, 0, 0, 1, 2, and 2, negative 8. So when the a is negative, so negative 2x squared, the parabola opens down. That's all I wanted you guys to see. So when that's a negative, the parabola opens downward. That's, hopefully you guys remember that. Okay, now let me show you what happens with the last one. So this, it's called the vertex form, which is like this. In general terms, that's how it looks. This is this. The vertex, when you have it in this form, would be the h and the k. That's the vertex. Whatever number's here and whatever number's here would be the h and the k of the vertex. The axis of symmetry for this one would be always the h, or the x value of the vertex, which is this is the x value of the vertex. So you denote it by x equals the h in general terms. Whatever the h is, that would be the axis of symmetry. So let's look at this one. It's already given to you. What's the vertex? That's the h, which is this one. That would be the first one. And I'm going to put a 2, and I'll tell you what happens because there's something else besides that. And what's the k would be the y value, which is 5. Now, that, whatever sign you have for this one on the vertex, you're going to put the opposites, which is negative. If it's positive, it's negative. If it's negative, if you notice, I put just an H, a positive H. It's always the opposite of that sign. The K stays the same. Whatever the sign he has, that's the sign you carry. The K you keep the same. What's the axis of symmetry of this thing? It's always that value. X equals -2. That's it. If you guys want me to graph that one, let me see if I have space. Don't. If you guys are graphing this one, just find these values. So -4, 1, 2, 3, 4, 7, 2, 3, 4, 5, 6, 7, 3, -3, 1, 2, 3, 5 halves, 1, 2, 3, 4, 5 halves right there. -2/5, 1, 2, 1, 2, 3, 4, 5, -1, 5 halves, and 0, 7. So that would be the graph of this one. 1/2 x plus 2 squared plus 5. That's a graph. So let's see what happened really quick compared to the original. The origin is here. Right there. 1, 2, 3. 1, 2, 3, 4. So this is the parent function. So what happens with the vertex of this? It moved 5 dots, 5 units, 1, 2, 3, 4, 5, and it moved 2 units to the left, 1, 2, and we land on the other vertex. So we went from here to here using these numbers. It went up 5, and the opposite of that sign, so to the left 2. And every dot, the same thing happened. The 1/2, it means it got wider than the original. If you guys notice how wide this function looks wider. It got fatter, it got wider. That's all you need to know for this. The axis of symmetry would be the line that cuts it in half. And I already put it here. It's x equals -2. And that would be the vertex, these dots. -2/5. This is a vertex. And that's it, guys. Thank you.